right, let's keep thinking about division here. So if I think about dividing by 3, any number that you divide by 3, either it's going to divide out perfectly and then would have a remainder of 0, or you're going to have a remainder of 1 or 2. Yeah? So any integer a, any integer a divided by n is going to equal some sort of natural number plus some sort of remainder out of n. Yeah? That remainder is going to be 0, 1, 2, ... all the way down to n minus 1. Yeah? So this is, in general how division works. Well, if we think about going back to our equivalence classes and relations, all integers, we can think about integer division by thinking about the different remainders. Yeah, so if we continue to think about dividing by 3, if we think about the remainder of 0, then our set of numbers is going to be infinite, really. So I could start -3 divides evenly, 0, 3, 6, 9, and so on and so forth. If I think about numbers that would have a remainder of 1, well, it's going to be all the numbers that are 1 greater than these. -2, 1, 4, 7, 10, 2, 1 greater than those, -1, 2, 5, 8, 11. And now I can see that I've got all the different set of integers. Individually, each of these we refer to as the residua classes modulo. Here we would have 3. Yeah. Note within these, always there's a difference of 3, because that's what we were dividing by. Okay, so let's go ahead and define A congruent to B modulo n. And what that is we've got n is going to be an element of positive integers. We could also say, well, we wouldn't want to say natural numbers because we're not including 0. So n is an element of positive integers. A and B are elements of integers. So we say that A is congruent to B modulo n. Our notation for this is A, 3 lines, if we're going to say congruent to. It's the same as saying exactly equal to. B mod n, if and only if A minus B is a multiple of n. So we could say mn, and m would also be an integer. Terrible, terrible. All right, so what we're saying is that A and B are going to have the same remainder when they're divided by n. Yeah? So think about that. You're going to have the same remainder if they're divided by n. They're going to be in the same class together. Yeah? So what we just said here, they're separated always by n. That's what we're saying here. The difference between them is some multiple of n. And any relation, if we have a relation, ARB, such that A is congruent to B mod n, then this is going to be an equivalence relation. So think back to what we just talked about, our definition of equivalence relation. Why is that going to be true? Yeah. If you want to think about the proof of this, go ahead and think about it. It's in the typed up version. So this is always going to be an equivalence relation. Yeah. See if you can prove that. Go look at the final proof. All right. So that is A congruent to B mod n. And these again are the residual classes for mod n, and we'll look at what this means in this next example.